Good afternoon. This is Suraj Singh speaking from Bharat, India. After many days, I just bring to you many more formulas duly formalized on a spreadsheet. I last time gave you many ones, same drawing, the same Excel, same worksheet is here. I just include many more formulas to you, which you like to see. I think it's mathematical work. We can say it's based on various parts of trigonometry as well as algebra, as well as you can say mensuration, but converted to cellular functions, cellular formulas, and I think. As you know, we discussed last time, and again we are going to see the same worksheet I'm saying, and we go if you go home to this one, you'll find that, as I say, I just to precise. So let's see what we have done so far. You see, we started with something that was very elementary. We started the formula generation. On many days, we started, I think, 15th November, then with many dates, and also I'm just submitting something today. And the last time submitted equations, various equations, or various elementary equations of 2 degree, 3 degree, like that, 2 degree, or you can say certain formulas. And then we went on to further geometrical shapes, which is very, geometrical shapes is very useful in computations everywhere, which was a square and rectangle, and then it was triangle, which is ordinary one, equilateral one, isosceles, high, right angle, and then right angle, triangle, and triangle with three sides, dimensions given A, B, and C, and then it is circle, sphere, cylinder, cone, parallelogram, and followed by rhombus, trapezium of two types, 1 and 2. You can say trapezium, which is symmetrical and non-symmetric, then polygon of various dimensions, various irregularity, various equal angles, and that's polygon 5 sides is called pentagon, then polygon 6 sides is known as hexagon, and polygon 7 sides, which is known as heptagon. Then it is polygon 8 sides known as octagon, and polygon 9 sides we call nanogon, and polygon 10 sides called decagon. And then we shifted to combination of these shapes, and we combined triangle, that is triangle ordinary, and triangle and circle. We combined triangle in circle, and then we did combine. You can say we subtracted. You can say square and right angle. We combined both. Then we combined. You call it a kind of you know subtract triangle from parallelogram. It was subtract means reduction, take out, and then it was subtract right angle triangle from isosceles triangle. And then we moved on to combine five-sided polygon, pentagon, and construct. That is, there was four four pentagons to be connected to square, or can say, as you can see, this is available here. And then we did, of course, add three five-sided polygons of pentagons to isosceles triangle. We worked on that and formalized all these, and then we went to subtract from octagon a hexagon. Hexagon was fixed in, the octagon is we did, and then we went on to your, that is, subtract from octagon a pentagon. Subtract an octagon from pentagon, and then we went on to subtract from decagon a octagon. An octagon, that is combined 31, and after that it was combined calculations pertinent, combined three number 10-sided polygon, decagon, 3 number 5-sided pentagon, isosceles is that one. And I'll show you some sketches, and this one. I'm sorry, this is, sometimes, clip something wrong. It happens like that, no problem. We are on way. And it is here. You might say that, yeah, it's this one. If you blow it up, you'll see what it is. There are, you can say, there are, you may say, yeah, you know, there are certain polygons here and triangle in between. We combine them, and then it's easy one, not difficult one. But now we go to well, I think to tell you what I like to show to you. This was application number 31 I just talked of. Combine three number 10 sided polygon decagon, uh, 3 and 5 sided pentagon on one isosceles triangle, which we have had, where I brought all this formula put here and use them. You can see matrix of this is increasing. It doesn't matter. Now what we did specifically post that time is swastik. Swastik or satya, some people call it. This swastik this swastik, everybody knows this. I think there's nothing specific in this, but this is known in east as well as in west both. East consider this as pious sign or healthy sign, or you can say a sign which gives you some good result, called swastik. Health as well as prosperity, it just is called this is like, while in west they consider it opposite to what we consider here in our country. Well, it doesn't matter, I'm not going to discuss with that. My approach is using geometry of that one, so I drew this satya or swastik. And this design is very automatic. I mean, you have to adjust these dimensions, so the square is made here, and you may call it 1 2 3 and 4 5 6, or you may call it 1 2 1 2 1 2 and 1 2. You may consider 8 arms here with one connection or intersection, and you may also call it 7 arms if it depends upon you. It doesn't matter. If you take it 1 2 and 3 4 5 6 7, or you can take 2 into 4 8 whatever. Swastik, and then I'll go to cruciform. This is cruciform, and let me see cruciform just to show you how it works. And then this is cruciform, very well. This is Bible sign, and this is the same 3 arms here and 1 long arm here. And if you go to after that, if you go to another sign, which is also very important, powerful sign, its shape, and that is, it's called Shakti sign. It means, or you can say, in other words, it's called male and female, like that you can say, or you may call it David sign. David means the Israeli people use David, Jews use David, but we call it differently. Devi, we call it. Shakti and Devi are same, so it's a question of spelling only. David. I can use it. Devi means mother, we call it, power of mother, and Shakti, both are same. So this is a sign of that one. We'll work on this, as well as we'll see how the combination of these work. Combination is always very important, how to use them in our work. So this is a combination of this. You can say here, just a minute. This is that I put one swastik here. This is one swastik here. Measured it and connected with this, around it, cruciforms. We worked on that one, and then we move to this swastik. Another one, but this is, we transported from here and put some for finding out this. Then we can say this is another sign, which is, you can say, same one as I said, this Shakti sign or Devi sign. This was this sign, and we explore this. In dimensions, so that this double line, you can see this sign everywhere. And I measured area, perimeter, and volume. 3D volume, pertinent this sign. This is what we did here. And if you go further, we'll see here. In this we use this one, and also there is rhombus formation in this. You may say how rhombus is formed, but I will show you how rhombus is formed here. If you see this here, these are rhombuses here. Though it's very small, but it is connection of these two. These are rhombuses here. So 1, 2, 3, 4, 5, 6 are on this triangle itself. There is one at corner, other corner, and so it's there. And this rhombus is here, so we transport it or we import it from there, this and there. Then it's further one, it's the same one, but we use a different way. We use this in combination with swastik. You see, this is sign of Devi or Shakti, or I can call it male and female sign according to your culture. Male and female connections or interlinks are known as power. And then you put signs around here and one in between. So there is an infill of 6, 1, 2, 3, 4, 5, 6. 6 signs, 3 and 3, 6 plus 1, 7. 7 swastik. One inside within this hexagon, because there are 6 angles of 60 degree each. This says this is equilateral triangle here and here. This hexagon automatically formed in this, and we can see that one at corner we laid a swastik here, so that this 7 and this one and this we just put in like that and measured, and this is the right formula of that. And this is another one, and this whole star. Have you heard of star? You might have seen a star, particularly American one, USA. They use a star for their symbols sometimes. And you can say this is that. This is a star here, five corners. 5 corners means 72 degree each, because 5 corners means you can say 360 divided by 5, you'll get that answer. And and this way we measured this by calculations, and that's what we'll discuss. And then you can say this is still in progress. This is not yet completed. This is also a sign of octa. Octa means 8-sided. These are 8-sided. This is just not completed. I'm referring to you. I'm also busy on many other shapes, which we'll discuss later on. So now I'll go one by one. I talk to you, and that's very important one. We'll start with this sign off here. This is we completed this before, I think. You remember that we completed this. We used here polygon, then we used here isosceles triangle, and we combined them together, and then it's okay, fine. Now I'm talking of swastika, and this sign is a little down, so it's by chance has gone a little up, so it should be a little down. Maybe due to some hopping, etc. it happened. It doesn't matter. So this is swastika here. This for swastika template. You can call this template, doesn't matter. You can call them template. I put just in line to that one so that'll be clear. Now what's construction swastika? Let me explain to you first that one. Otherwise you may confuse, means while I'm talking irrelevant, you can't understanding that one. Right. Now I use this A, you can draw this swastika yourself, you know how to do it. It's nothing new. On walls everywhere you draw it in our country. But let us say geometrically we define. I consider this arm, one arm, and the same thing applies for all arms. Now what is this arm? Say A, I put dimension A here, just to give symmetry, just to give, easy equation. Equation formation is very easy. In geometrical consideration, particularly when you have to spreadsheet or worksheet, that's very, very important. If we are successful in that, we can move to whatever level we wish to move. That's most important. So now I say A, then we have to see how we proportion this. The proportion is very important. These 4 must be equal in size, in dimensions, as well as in height, or you can say perimeter, whatever it is. So I say A. Now I put 4A here, and then 3A here, then 4A here and 5A here. So A, 4A, and 5 automatically comes in. And same thing, there's a common here, this common connection here. We just stop here, we stop here, stop here, and stop here, and take this separately, A and A, because continuous. So similarly here, same dimensions, just you move this at 90 degree minus, you got same, if you move this L minus 90, you'll get this, and Then you for move 90 minus or this way, or you can take this way, move like whatever way. Some people take it this, but this right way, and some people take it otherwise. Means area remains same whatever way you take. So we have A, 4A, 5A, 3A, 4A. Then I have a small layer, but it's the same A, starts with A, 5A, 4A, and here this 4A, and then like this means it moves. So we now go on to see how we're done in swastik consideration. So let's first do this. So so it's down now. Now why I did actually, let me just blew it a little so that you can see clearly what we've done, because I just okay. Now we say swastik, spatial shape is swastik. Dimension A we put there, as we start with their dimension, consider that variable. The other dimension results depends on this variable. So I put this variable, and this is agitable cell 10 or 5 or whatever you take. Yellow color indicates variable. Then I say one number arms equal to two members orthogonally. These are two members orthogonally. Okay. And area is equal to, I say A into 5A, A into 5A this area, and then plus A into 3A, because this remains 3A. So A into 3A, this is 4, 1 deducted here. So it becomes A, 3A into A, same thing you can call it. So area here is A into 5A plus A into 3A. We have area of one arm. Okay, then we go number of arms. There are 4 number of arms. Is very clear. So we use area of one arm for 4 arms, right? Number of arms of 4. So area of 4 arms is equal to whatever area we got there, multiplied by this number, we get this answer. The intersection of arms, this is intersection we call it here. Intersection of arms equal to one number. So we say A into A here. Then move into total area, means area of this plus this intersection. So when I say A, whatever you use, A into 5A, this you can say, this is A, B4 to 9. In this case, you can say into 5A, 5 into A again, plus we say A into 3A, A B4 to 9 into 3A. So we get this answer. And we apply this to 4 numbers, so we get this multiplication here, and we get this answer. We can't change 4 numbers. It's not variable. 4 is fixed one in this case. Though it's not formalized, that's fixed one because there are 4. You cannot use 3, you cannot use 5. Whatever it is, it's the same. 4 arms will be there. So area of 4 arms is there. Product of this A1 into 4, you get this answer. Now intersection of arm is one number, and it's that one, B4 to 9 into B4 to 9, because it is A into A square meter. Now total area. What is total area? Area of 4 arms plus intersection, and that's this one, area sum E4 to 9, sum E4 to 9 plus F4 to 9. You can do it this way, or you can take this way. It's up to you. I just put comma and another cell, but you can combine these two and say like this, means it doesn't matter. What I get my word, if I say this sum into this, and we can say this into this, so this is the same thing as that one, or it's same thing as that, doesn't matter. So you take your way, whatever way it places you use that one. But we have to do every method, we have to do every as a style of formula, so that we understand what is minimum and what is maximum requirement. Formula has no limit, we can go to whatever extent. Now parameter, which is in meters, is a 1 arm parameter. First we have to see 1 arm parameter. That's A plus 5A plus 4A plus here 4A again and 3A. Got my point? One is A small, then 5A, then 4A, then 4A and 5 and 3A. So we use this one, B4 to 9 here, plus 5B4 to 9 because 5A, then 4B4 to 9, then 4B4 to 9 again, and 3. So we get parameter. We get this parameter here, like this, this parameter we get by this. So this is a parameter of 1 arm, so parameter of 4 arms, you have to multiply 4 naturally. So this H value and this value of D, and this is D, which is 4 numbers, so we get this one. So volume, now we got what did we get? We got parameter, we got total area, this is total area here, This is total area, and this is parameter here. I just highlighted that. Hold on. Let me say total parameter for all. For all is this. All right. So we have total parameter, and we have total area in square meter, parameter meter. Now this is for two. This is for planar calculation. I'll move to what extruded calculation, that is 3D, and the 3D is how to do that. Means extrusion volume. In vertical extrusion, we call it, when you have a planar figure, you extrude vertically, particularly to get volume as well as surface area. Volume, we're talking whatever depth, because it's a variable here, and I'll just change because it doesn't look nice here. I'll put this way, so it's okay. This is depth, which is variable, and it's 5. So we have one variable here. There's dimension A, other variable is depth. Now we use this for volume. Volume is what? Surface area, I mean to say, area which we calculated, that area, this area, multiplied by depth, that's at 5 or whatever it is. So you can say volume is total area into depth. So what is total area? G429, this is G429 is this total area into J429 is, so we get volume cubic. And similarly, is a surface area of surface area, means this end areas, this end and top end, both bottom end and top end, and vertical surface. So 2 into end areas plus vertical surface square meter. So we say 2 into end areas, 2 we have to keep to here, G4 to 9, here it is total area, which is now we choose the top total area and bottom total area. So this is twice, plus we say vertical surface square meter parameter miscat. We have parameter here, that is I429 and J429 is J. So we get total surface area. So we have volume and we have surface area. This was the basic requirement of this diagram or this shape. You got my point? This is one, and that is called swastik. So swastik is over in this case. Now we move on to a other one. This was application. I think I forgot to write. App number doesn't matter. We'll see later on. Number can be changed anytime. So this was swastik. Now app 32 it is. What app it is? It is 31. So this is 32. So by chance it's on this, no problem. Let's go to cruciform. We go to cruciform. Cruciform, you know very well what is cruciform. Cruciform is known to everybody. Generally people call it cross, though it's not cross. It is one vertical, or you can say one long arm and 3 short arm. You can say one short arm and other long arm. You can say that. It's up to you. So what we, by purpose of notation, we have taken cruciform, and dimension we just take same as A here, just like we did in case of swastik. A here. Now one number arm, there's one number arm. We have 3 arms here. We take like this and take long arm like this. It's up to my way, your way you can do, because we have established variable. A, one arm is this, so here is A, and this is 3A, and this is 4A, is given here. This is, I think, 4A. Let me be sure how much is this. Just a minute, please. It is A and 4A, and this is 6A. So this is A, 4A, and remaining portion is 6A here. This is 3A, so these 3 are equal. These 3 are equal here, 3A, and this is 3A, 3A, and 6A. It's like that. So we can say now, that this is 3 number of arm is A into 3A, A into 3A, A into 3, and this is A, B436 into 3A, B436. So, and then we see number of arms, 3 orthogonally. These are 3 orthogonal arms. So we say 3 here. It's not variable, it's fixed because we can't change there. Area of 3 number arms, area of 1 arm into 3. It's given here. This is a formula. So area of 1 arm is, this is 1 arm area, products this and this. We get this one. Now intersection is this one. Here intersection we have to take, which must be A by A. So this is A by A, and A by A is this B436 into B436. So we get this. We have taken area up to this one. Now this area is required. Well, area of long arm, the area is A into 6A, A into 6A. This is A here, as we say. A is 436, B436. into 6A, 6B436. So we get here both, we get long arm and we get 3 short arms. We got both areas. So total area is area 3 arms plus intersection and plus long arm. These 3 areas, intersection and this is long arm. This is what, so I say sum of what? E436. This is E436, area of 3 arms, and G436, this is area of this one, long arm, and we can say, hold on, yeah, E436, 2G436, E436, F436, G436, we take total area of this end of this. Now, perimeter. What is perimeter? Perimeter 1 arm is equal to A plus 3A plus 3A at parameter 1 of one arm, that is A, this is A, I'm talking one arm, A, this is 3A and this is 3A, so one arm is this, A plus 3A plus 3A, and that's that. A is this B436 plus 3B436 and plus 3B436, so this is parameter of one arm. Then we say that equal or short arms, we are saying equal or these 3 are equal and short as well as, so I put equal here, so there should be no confusion. You can't say I take this arm up here, no, that's not possible in this case. So perimeter of one arm into 3 arms, so this parameter of one arm is 4I 436 into D, which is 3 D436. So we get total parameter of this. Now these 3 arms are solved. Now because there is no parameter inside, this line is disconnected because it's continuous. The parameter is only here. We forget this intersection. That was for purpose of area, not purpose of parameter. Parameter 0 is what we do. Total long arm, now we have to consider this long arm. And this long arm is 6A is vertical, then A and then 6A. 6A plus 6A, and this is that 6A plus 6A, and we have this one. So total parameter is short arms plus long arm, and short arm is here. This parameter, and this long arm parameter. Got this? So we have parameter of I436, a parameter, previous one. Then we have long arm parameter. So both are here, and we get, I parameter, one arm is this, parameter I436, and J parameter of one arm into 3 numbers. Well, I think the parameter of one arm is there. That's parameter of one arm, and then parameter of one arm into 3. That's this number. So we have long arm parameter is this. This is 6A plus 6A. So we have total parameter now. Short arms plus long arms, we have to check that. What is short arms? We have taken I436, parameter one arm, and this should be equal short arm parameter. This is actually J, and J is that, and long arm parameter is this. So this should be I436, rather it should be J436 in fact. I think equal short arms is this, long arm is this. Total parameter is saying this, I436. It's for 1, right? It should be this one, J and K. Well, this is this. Let us say sum is I, sum is J, equal short arm parameter is this, plus long arm parameter is this. So it should be actually this one. So this is that, okay? So this is I436 into D436. D436, 3 numbers, okay, that's okay. This is that one for 3 1, that is, parameter of one arm I436, this is one, into D436, that's this one, number 3. We got this parameter 3 arms and this parameter of longer one. 3 dimensions are there, and we take sum of this, sum of J436, K436, we got this, right? Now that's parameters over, area is over. We have the total area here. This is total area, this one, and this is total parameter. This is this one, not this one, sorry, this one. Total parameter, this one. Now let us say depth or 3D, which we call volume and surface area. Formula principle is same as we talked of swastik, only on the dimensions are different. So volume cubic meter is total area. We have total area of the surface, which is here, total area into depth. H for 360 total area into M for 360, as we get vertical volume. But surface area is 2 number ends areas plus vertical surface, and that is 2 number H. H for this is H for 36 vertical area or surface areas of this plane figure twice plus L 46 total parameter into M for 36 height. So we got this. So our cruciform is also solved to an extent. Area is concerned, parameter is concerned, volume is concerned, and its surface area is concerned. We have resolved two cases. One is swastik and other one is cruciform. Now we go to complicated one, and that is Shakti or Devi, David Mark, which we discussed here already. What this figure says, that there's a triangle here, this equilateral triangle, and there's a triangle here, equilateral triangle. We have to consider equilateral triangle for this because there are six corners we have to produce in this case, and equal angle corners. So equilateral, we call them. These 6 triangles must be equal and surrounded by, these triangles are surrounding this hexagon. This hexagon inside automatically, side of hexagon, this base of hexagon and base of this equilateral triangle are same. In this case, they are same. This is A, this is A, and this is A. Similarly, A, like this, all are same. So there are 6 triangles and 6-sided hexagon. And combination of this, you can call it Shakti Devi. And this 60 here, 60 here. Of course, when it is 60, it is 120. So we will now, you got my point, this angle is 60, 6 equilateral triangle, and 1 regular hexagon within. So we have to consider equilateral triangle area and parameter, and we have to consider this area of hexagon, and then we can find out how Shakti works. So let us see how Shakti works. Okay, we go there like this. So let us say how Shakti works. We discuss the one now. How does it work? Shakti Dima. Let us see how it's working. That's very important point. It's really working. I'll get to see whether it's moving or not. Sometimes problem in video. Not receive the signal from video source for some time. Check that. And also saying that check the face. Not receive video signals. Not receive video signals. It's not receiving face. Not receive video signals from video source for some time. Check that. It's coming. Not receiving. Not receiving. I don't think I'll get this done. What to do? So video says change from free live to live series, service video signals, live. Well, I don't know. I don't know I'm getting my work done or not. I can't say. But let me go a few for more. Maybe it works. It depends. Now I go to Shakti sign, and that is Shakti or David, and this is here. Dimensions is here. A, we consider this 10 or whatever you can consider, it's up to you. But there is a problem in this other area when we give double line or single line is not a problem. I mean, we are consider single line, so it's not a big deal. And it is external equilateral triangle, 6 numbers. We are saying external. I mean to say this I'm considering external, right? So it's external equilateral triangle, 6 numbers, and internal hexagon 1 number. Internal hexagon must be there. You know this I'm talking of. Internal hexagon here. This is internal hexagon. Now we say internal hexagon 1 number, and then you can say area of equilateral triangle. Area of equilateral triangle. Now we have to find what is area of this triangle. Though we have equilateral triangle with us already in some other apps. So in some other apps we have this applications. We have already application of equilateral triangle. We will take that one which I put here. I can put here that already. I put polygon as well. Yeah, hexagon polygon. and we use this for interconnection with this. So what these columns say now, equilateral triangle we understood already, we've gone through this polygon, regular, hexagon, we've gone through. I copied them here with these sketches. And I say internal hexagon one number, and then you can say internal hexagon one number, and then area of equilateral triangle from application. That's your protein is here 43, whatever it is. D445 it says, so here is D445. That's D4 for area here. Template from template. The area of 6 equilateral triangles, you know, area of 1 we have, 6 we have here. We can say this multiplied by this, we can get this one. C here 442 into E 442. So it's here, answer. Now area of one internal hexagon from application, that is this one. Area of one internal hexagon, this was equilateral triangle. Now I'm talking of hexagon, and this hexagon here, hexagon, this is area we calculated here out, and this is hexagon area, that is 450, I450, and we can say this is the one. Area of internal hexagon is D442 into I450. That's area internal hexagon. That's 259. Hold on. I think maybe yeah, it is okay. 259. This is total area. 450 I. Why 449? Hold on. Top trapezium. Maybe I made a mistake. Let me check it. Total is this polygon regular. This is this one. 450. I450. Sum of H459. I449. And this is this one. Okay, this is that one. Now, this is result 450. I450. So I should say total area of 1 is this one. So it's okay. It's 259. So here is 259. Area of one internal hexagon is this. D442 into I450, D442, D442, yes, D442 is number 1, and I450 is, yes, it's okay. Okay, it's okay, there's no error, it's fine. So we get area of 1 is 259.81. So we have to find area of 1. Area to the area of 6 number equilateral triangles. Now this hexagon area we have, now we have to work out 6 number equal triangle, which is equilateral triangle plus 1 number internal hexagon. We got the total area we're talking of. There are 6 number equilateral triangles and 1 number hexagon. We will sum these two. So this is area of 6 number equilateral triangles plus 1 number internal hexagon. This area we apply. So we have here area of 6 equilateral triangle. This is sum of this and this. Sum of F442, and this is G4. You add these two, you get total area of these equilateral triangles and 1 number hexagon. So this area we got in here. A perimeter of one equilateral triangle. Where is that? We have to go to this equilateral triangle and see perimeter. Where's perimeter? Perimeter is, this is here. Perimeter, this is perimeter here. 3. So this is perimeter 445 E405 perimeter. So it's E405. The perimeter of one equilateral triangle. Perimeter 6 equilateral triangle. So we can say this multiplied by C422 or 61. So we get perimeter of 6 equilateral triangle. Now perimeter of one number hexagon. Perimeter of one number hexagon. This is hexagon here. Polygon. Perimeter of this is perimeter of this is what's that? Yeah, it's here. It's here. 452C. So this is 452. So C. So C 452. Now total perimeter. Total parameters, we have to find parameter of 6 number equilateral triangles. Equilateral triangles, you can say total parameter of one hexagon we got, then total parameter of 6 number equilateral triangles. I think there should be something else or no. Let me see, maybe it's hidden. Yeah, no, it's not that. Well, total parameters, parameter of 6 number equivalent triangles. Of course, that is J442 and J442 pair of 6 number equivalent triangles, and we can say total area and areas. For finding this parameter, we have to use what? Total area of and both and areas plus parameter. We are taking this parameter of 6 number equivalent triangle just because we are taking this with this and this parameter. We are saying this, there's nothing in this, this parameter here is the first parameter is this. When we are taking these parameters, we are taking these parameters, we are taking these parameters, these parameters, and these parameters, and these parameters, automatically hexagon will govern that. That's why we are taking only total area of it. This is total parameter is this parameter of these three, and we have taken 6 number triangles, and so a hexagon is there automatically included in that. So what do say? Say that. Hold on, please. आगे मुझे खोलनी पड़ती है या all people disturb me. Sorry, gentlemen. I had to open. I cannot walk, so I had to open window, door. Sorry, disturbed. No problem. I continue. So we have talked parameter of this these triangles, which includes parameter of hexagon, and that's why I say here total parameter is equal to parameter of 6 numbers equilateral triangles. Here we did it. Then we have to find surface area, total area and areas of 6 equilateral triangles plus 1 hexagon. So total area means we have to find this area. That's where it is. Sum of H 442. This is total area here, equilateral triangle plus 1 number hexagon. This is area here, and 6 area of 6 equilateral triangles, that is these areas plus hexagon, that's total area. That is sum of here 6 numbers triangle, and I, that's here perimeter in the triangle. So we got here, total area, that is and areas of 6 equilateral triangles plus 1 hexagon square meter, that is area. We got it. This is this one, total area plus perimeter of, I think, total area. So 519 total area of 6 number triangles plus 1 number internal hexagon, that is this one. We get total and area. And what we say now, perimeter of 1 number hexagon from map we have taken, that is here 60. So we say total perimeter area we have here, total area of 6 number triangles. So we got this area. So that's a bolded it. And total parameter is here, the 6 numbers equilateral triangle a perimeter of 6 number equal triangle. This is 30 is 30 is 1, so it is J442, that is this one, perimeter of 6 number equal triangles. Now we say total end area of 6 equilateral triangles plus 1 hexagon, that's in square meter, and that's here. Sum of H442, that's here, area, and I area is this error. I think it should be cleared. Total area and area of 6 equal triangles of hexagon, and hexagon area is total area of 6 equal triangles plus 1 hexagon. That's already there. So 6 equal triangle, 1 internal hexagon, 592. I think there's some 4 H442, I442. Hold on. Total area of end areas of 6 equilateral triangles plus 1 internal hexagon. So it's actually this one. This itself it is. So 519.62. Same it is. 6 number equal triangle, 1 number internal. This is the total area and area of 6 equal triangle. Now depth is now this is superficial area. You can see this end. So we have to multiply it by depth. Let's say depth is 10, and depth is 10, or it can be whatever, doesn't matter. We say 10. So, and we can say that volume is product M4 for 2 into this. So we can say this that 10. 10 can vary. Just like dimension is here, so 10 can be here. So you can say 10 can be different. It can be, like we can make changes here, or we make changes here. This is variable. Depth can vary. If this varies here, means here also it will vary. You can say here, for example, it says here, where is depth here? Here is depth. In this case, polygon regular, equilateral triangle, and this is where is that? 3D. Yeah, this is 3D here. So depth is this. So N442. So this is N442 here, and also this is other one. That's other one here. In this case, triangle, and that's in case of equilateral triangle and polygon. This also depth here. Vertical volume is this N442. Both are there, so it doesn't matter. It's okay. That's variable here. Same will come here because we are using these two calculations, these two templates. So we have to accept it here. We change here automatically, just like here. I make it 5. You'll find the changes here. So it will be 5 here. So this is 5 here. Here is 5 and here is 5. So it's that one. Now we have to see volume of this 3D. What is volume? Total area of this surface, 6 equal triangles and 1 hexagon depth, and 1 hexagon into depth. So this is product is M442, N442. M is this area, and N442 this is depth. We multiply, we get this answer for volume, and for surface area, which is 2 into end areas plus total perimeter depth. And this is 2 into H442, 2 into H442. That is this area here. This area, both areas, plus and then this end and that end, plus L442. L is here. Total perimeter of 6 number equal triangles. These parameters, right? But remember that because what we have to do, this is 2442 plus L442. L442 is this total perimeter of 6 number equal triangles minus 6 BB422, B442. B442 means, this is B442 means here. This dimension, because when we are saying surface area is this. Surface area is this. This is one figure here. Once you close this from top and bottom, you'll find only exposed portions are in elevations or in vertical surface. This will not be seen, so we cannot take up this one because this is closed end at both top and bottom. So we have taken 6 deductions here of hexagon, 6 into this, and then N442, which is depth. So we got this one. So that's what we have worked for computing Shakti or David. We have used in this hexagon as well as we have used in this equilateral triangle, so that it is constructed well and we know what this mark of David or Shakti sign is. So we have worked over this. Now we move over to swastik plus cruciform. Swastik plus cruciform, which is this one, as I explained to you. There is one swastik and there are 4 cruciforms. We combine them together. We are going to work out their dimensions, their areas and parameters, as well as we are going to work out volume and surface area. So requirement is same all over. We have to require swastik template and these cruciforms. So we have here, there is a swastik cruciform. We have swastik template here. You say this is swastik template here, up to here, and then we have cruciform template here. Just now we discussed about. So we have to see now what to do, that how to work out. It's easy, not difficult, but it's a little time consuming, and time is important in every calculation. That's easy one. Now let's say this is swastik. First of all, there are 1 number swastik and 4 number cruciforms, and we have to work on area square meter. Then it says, let us say 10, as we took before. It's 10 and 1 number swastik, 4 number cruciforms. Then 1 number swastik area, here it is. We go through same swastik dimension here. This area of the swastik, we have to see that. Area is this. Here it's 464. This area of 1 arm, 4 square meter. And we know here it says that swastik area is this one, D458. 1 number D458, G464, and G464 is this. This is G464. Area 4 arms intersection plus intersection. Area of these 4 arms plus intersection. This is this, and this is what we have taken here. Area of 1 from template, from 1 swastik, from swastik template. Means once we have template, we do not need to check it again and again, and we can do one thing only. This 10 which is here free, where we are not currently free, so this one will link to this one. See, here, swastik is here, not there. This is 10, so this is our one, parameter 10. So this is here 10, and here it is C458. So this is linked to this one, and also here also same thing, C460, and this is this one. So it's all linked. You can link directly from here, no problem. Now we have area of 1 swastik, and we have cruciform area we have to find, and this is cruciform here. Cruciform area is here. We got 4 H468, and this is arms, 3 arms, arm 3 plus intersection, long side. So this is area of 1 cruciform. This area is here. So we have worked on area of swastik and area of cruciform. We have area of cruciform 1 number here. So we have 4 ones. So we say here 4 is here, E458 and G458. We get area of all cruciforms. Then we have the total of this one is 1 number swastik area plus 4 number cruciform. So we say that here the same we apply sum 458. We have 458, that is 1 number. There is 1 number swastik here, and this is H458. This is 4 number cruciform. So we get this answer. Now we say depth, let us say whatever depth is. So what we do, now 3 do vertical extrusions. I'm saying put here vertical extrusions. Swastik volume, that is cubic meter, is called 1 into area into depth, and cruciform volume cubic meter plus 4 into area's depth. Got my point? So what you say here, say swastik volume is, this says 1 D458, this is 1, of course we are taking 1, it could be then F458, this is area here, so we got 1 into area. For 1 it is, so we got same. Because we multiply by this j 45 for depth, so we get this volume. We got this volume. Now cruciform volume is equal to, cruciform volume is in cubic meter, that's 4 number around 4 number areas into depth. We have, say, 1 into 4 number areas into depth. Areas of, because there are 4 cruciforms, so we have to take area of 1 and multiply by 4. That's what it says cruciform volume is 4 number actually 4 number areas into depth. So actually it should, no, just error it is 4 areas into depth. So 4 is HF. This is H5458. H458 area into, this is depth. We got 6400 is here. 4 number areas we have already, and we have to multiply it. H458. H458 is that one, J458 is depth. This and this. So we get 10 times of that. So total volume is now what? Total volume is some K458. K458 is 1 and this is L. L is this. So we sum up these two and we get total volume. Now it's okay, volume we got. Now directly volume, we can say direct volume also we can get. It depends, means 1 swastik area square meter plus 4 number cruciform areas. 1 swastik area I4 is same thing, means just another way. But results we have worked out on this combination of these areas. Now area is over, but we go to now other one, and that is area was over. Now we go to parameter. This parameter. There is confusion of parameter and parameter. Now see, although the parameter we're talking, area is over. Size 1 number swastik plus 4 number cruciforms. We have already parameter here. We have same values as above, and we can say that same values here. And 1 number swastik parameter is equal to total parameter 4a. This is 4a. 1 number I'm talking of. A into, say, what is parameter for 1 number swastik parameter in meters is equal to total parameter into 4a. Let's see how much it is. D460. D460 is this 1 number into I464. I464. This is that parameter of 1 arm into 4 we are taken from template, and this I464, this parameter of 1 arm 4 into 4 arms. So this is their parameter. What we do, total parameter 4 into A. So we say D460 is there, 1 into 464, I464 is there, it is here, I464, so that's parameter of 1 arm. We have the total parameter of this. 1 arm is this, so this is parameter for 4. Now it says 4 number cruciform parameter. This parameter we are taking from here, that is one number 46001 here into I464, I464 is this parameter of one arm into four arms. So we got these arms here. We got arms here. Parameter I'm not talking intersection because there is no parameter in intersection. Keep in mind. So it is parameter of 4. There is no question of a plus a plus a plus a because this doesn't exist in parameter. So there is a difference here in 680 and this one because there was something else. Now 640, it's here. I deducted 4 into C460. C460 which is deducted, that's 7 because it's part distance. So you can say 4 number cruciform parameter, so total parameter. So 4 is this one. E460 is 4 into L468, 468, and that's here L468. Yeah, short arm plus long arm. This one we have taken this from here, 4 numbers, and we got it. 4 number cruciform parameter is equal to total parameter minus 4a. Total parameter minus 4a. That is 4 number this parameter minus 4a. We have taken out this 4a. So we got this parameter. Otherwise we would not have. Now depth is 10 meters. So what is phosphoric surface area? And what is that? It's also important here to think of. So depth is 10. We are considering and swastik surface area square meter is equal to end areas plus parameter into depth. So end area is how much? That is 2 ends are there. 4 F 458 F 458 is their area. Twice this plus F460. F460 is here. That is parameter into height. Height is here. J460. So we got this parameter. Depth means is height of depth, same thing here. And then we use the cruciform surface area. This is cruciform surface area is because this was for swastik. Now cruciform surface area is 2 into end areas plus parameter to depth. So it is 2 into H458 and H458 is this. 2 into H458 here we taken plus H460. H460 is this cruciform parameter, total parameter into J460. These two and height is J460 is height. So we got this. So you can say we solved this about cruciform. Now we solved this cruciform. So swastik surface area is this. Cruciform surface area is equal to this one. We got these two areas. If you wish, you can sum them up or you can leave them separately. It doesn't matter. It's up to you what you want to do. Work is done here. So it says 1 number swastik area square meter plus 4 numbers cruciform areas, and that is here. Say here. So, okay, fine. Now we move on to Shakti Devi, which is very, very complicated now. This is the figure, which is very much professional in itself. You can see that. Can you understand that? If you can understand that, understand the verses. Actually, it's something very, very communicable and mind consuming because it's not only here. It's very much, it's very much, what it says. This sign that we have taken, we have made double line on this, means we have given width to these lines. We have given width to all these lines, 3 lines here and 3 lines here, and we have given some width to all these, so that a physical sign is not line diagram alone, but physical diagram where area of these 3 dimensions can be measured, and by that there are, if I just blow it further, I'll show you what there is actually. You can see that. You can see that these 3 dimensions are there, and these are double, as well as these rhombuses are there, and all these are there. And these people, the dimension only for my purpose, not for your, because we are talking in units of A. So what we are talking is this A, we have as before, this angle we know, this A we know, and then there is, we can say I've taken this as A is this is A. I mean this is A, this is A, and this is A, and this is A. So all dimensions are 3A, 3A, and 3A, 3A, and 3A, and 3A, and A, like that. So this is now, this is, you can say, this is A, but I say because there's a rhombus, yeah, because of the ball line, this dimension of rhombus we have to find out, and we have to find out height of this so that we can understand what it is. And in this case, what I'm taking is I'm taking A, this as unit. This A is unit of one triangle, and 25 I'm taking here, though it's only 25, but there's a formula. I'm taking, of this dimension 25% here. What is A? So I'll say this A over 4. Like that, we will measure for purpose of driving our formula. That's what we have to go with, is that. So that's that way we can say that is what Shakti Devi is about. This is little complicated, but very, very interesting, because as I am moving towards complications of formulas which are very descriptive in mathematics, this will take some time to understand, and also to understand philosophy behind that, how to it's a kind of unknown macros, means you're not applying any language here, you're not going to apply any language or macro or something like, or I should say algorithm. Is different kind of connections and links to cells, cellular connections or cellular links. These are very much important for purpose of driving our formulas. So this is what says now. It says that in this case we have to pull in our rhombus. We put rhombus here, and we put also here, here's rhombus, and we put here, I say, hold on, put this Shakti, it's rhombus, yes, and so Shakti, we need Shakti, so we brought Shakti here again, because we have to expand that Shakti. So this template is that one, and dimension this A, we keep external triangle arm, I said, external triangle arm, I am using this one for purpose of our variable. This is for purpose of our variable. Why I'm doing is that I'm saying external triangle, we have seen this then. Shakti Devi diagram arm is 3A. Arm means this arm. This A, but this is whole 3A, and this is A, 3A, this is 3A, this is 3A, this is 3A, and this is 3A. That's what I'm saying. I'm not going to dimensions, I'm going to notations. This is 3A, so of course it is 10, it is 330. Then we say W factor A. What is W? That's the point here. Width. It says it's width of this. This is W. I'm writing 25 here, but I'm considering this a W. Just keep it in mind. Like B here, H here, and W is here. That's what here. So this is W, which is a factor of A. W is a factor of A because A is this. This is W. A is here. A is this. This is A. We're not given any dimension to that, just A names A, and the in relation to this A, factor is W, and that is A into something. What is that something? That is, I'm saying 0.25, for example, 0.25 or 25% of A. So I'm relating this equilateral triangle dimension to width of that arm, which is 3 times 3 times triangular measurement. And that's very important, triangular side measurement, and 25% of that I'm keeping. It can be 20%, it can be 30%, depending on you as far as it works. There should be no negative, only positive dimensions we have to take because it's a physical entity. Negative doesn't work here. If it is negative, this means there's a clash between this, and we are losing some area or dimension. Now, width of arm, that is, we consider W is equal to A into W. What's that? We say A into W is factor. Factor is that, A to W factor. What is W factor? Multiply by the factor with A. So we get here D475. D475, which is here, that is size, and multiplied by B475, that is D475 is here, factor multiplied by this A, so we get it 2.5, which is width. We consider this arm, width of arm. I'm not saying width of this, the arm is width of this whole arm. This is arm. So this W factor and this line multiplied with width of this, so that was I'm saying here. Width of arm, right. Now there are two ways. We are concerned with angles here. We have here certain angles. These angles are 60, I want to external, 60, 60, 60. And when we say, if we draw a vertical here, rather than 60, this angle shall also become 30 here. Because this is 90 degrees here, this is 60 here, it shall become 30. So what I'm saying is, we have certainly 60 here, 30 here, cos 60 here. So I just put values of tangent 60, tangent 30, and cos 60, because we have to find these dimensions here. Perpendicular, we do not know. We can find it. Perpendicular upon base. Base we have A over 2. Perpendicular to base. Angle we have. So we can find various dimensions here. So we just put values of, because if directly put in a cos cell, maybe some confusion. So this is our tangent 60, pi over 180, tangent 30, and that's we got. Now for width, that is B over W. Tangent 60 means width is that. We can say that B is W tangent 60. What is B? That's what I'm saying. First of all, let's remind ourselves what is B. This is B here I'm talking. This is B. Where my point means we made a triangle here. And base and connection I use with that. That is B is or W is tangent 60. Means width is now base actually. We take equivalent of that. So you can say B is a kind of perpendicular in this case. Perpendicular base is W. So we can say B is equal to W is equal to tangent 60. So B is equal to W tangent 60, and that's this one here. B is equal to W tangent 60. W tangent 60 E475, that is E475, it's here, into F475, that's here. So we get this value. So what we got here? We got B, so W tangent 60, W derived from this variable, this formula of A, and we got in factor 25.25, so we got B of that 4.33. Now we are going to think of area diagram apex up and area diagram apex down. What is apex down and what is apex? That point we have to understand here. This is apex up. This is apex up, this triangle, and we are considering this triangle apex down. Apex down and apex up. This is notation here. So what is apex up now stating? Apex up is stating something, and it's requiring arm, this arm, whole arm, 3 A's are involved in that. arm, that is internal one, at the internal of trapezium, that is internal of trapezium. Which trapezium? That's what we have to think of now. Which trapezium I'm talking? I'm talking, I'm talking something which is, you should understand that. If you see closely here, you will see this arm, right? This arm, and we have given the width of this one, and this is another arm, right? Now I'm saying vertical here. Certainly it shall be here. It's vertical here. At 45, at 60 it will be here. So where this meets with this one here, this line and this line. This is line, and this is another line, longer one, and this inclined vertical make one trapezium. You understand this? This make one trapezium. And this trapezium I'm calling here, or I'm saying with dimensions, and that is this dimension. If we calculate this dimension is 3a, as it is 3a, this dimension is 3a, and we are saying b this way and b this way equivalent. So if we say 3a minus this b and minus this b, you get this dimension. So you can say if this is a trapezium, even this is lower dimension and this is higher dimension, and higher dimension is 3a and lower dimension is 3a minus 3b, 2b, and you can say this is the height. It is already there, we know this, or we can even find from there. That's what I'm calling it now. We say apex up and apex down. So it says arm, the internal of trapezium, internal dimension is 3a minus 2b, just now I explained to you. So this is C475, C475, let's say 3a minus 2b, and b is I475, that's this one. So we got this internal dimension of trapezium or lower dimension of trapezium. Now it says diagram arm trapezium. We are calling a diagram, or we can call it, but if we say it's a diagram of arm, diagram arm, trapezium area, we have to find the square meter, external plus internal side. We got external interdimensions, sum of them to be divided by 2 and multiplied by depth or width in this case. So we got this one, C475, we say C475 plus J475, which is not calculated. Sum of this in half and multiplied by E475. E475 is width, so we get area of this trapezium. So it's very, very small, but when you calculate something, you have to calculate to near accuracy. You cannot just move off without anything as such. So we got this area of trapezium. Now this is for apex up triangle arm area. It's called the 3 into trapezium area, because how many in this triangle we are talking of this triangle. We are calling this up, apex up. So in this triangle there is one trapezium here, there's another trapezium here, common between these 10, and there's another trapezium at base. So you can see there are 3 trapeziums here. When there are 3 trapeziums here, what we know that apex of triangle is called 3 into trapezium area, so we got 3 into K475, so we have this area. Now we are going to area diagram, apex down. Now apex down in this case is a question mark in a way that we are taking full area for up case, Can we take that for down case? There's a question mark, because we see diagram here, this figure will say we have taken full course here, full plane, but we cannot take full here. This is not permissible, because the crossing, it's cutting here, and it's cutting here and here, and it's 1, 2, 1, 2, 1, 2. 6 points it's cutting and producing rhombuses. These rhombuses producing the same thing as it was there, and here's it's rhombus 1, 2, 3, 4, and 1, 2, 1, 2, and 1, 2. This 1, 2, 3, 4, 5, 6. 6 rhombuses it's giving, separately here. This is where to tackle what we do in that case. That's a very important point. So apex diagram, area down is apex down or apex down or apex up area. We got area already there, that's for up triangle, so we accept that equivalent to this one, minus 6 number rhombus area as I just showed to you. 6, 6, 1, 2, 3, 4, 5, 6. Let's remove these 6 areas from this area because this area and this area are equal. So these cross factors are coming in 1, 2, 3, 4, 5, 6. We have to remove these 6 here. Area down effect, so apex up area minus 6 rhombus area, and this is the answer. L475 is the one, minus 6 R75, R475, R475 is here. This rhombus area, yes, rhombus area I just explained to you where we got it from. We got it from here, rhombus area, and we got template of rhombus here. So we can say, where's that rhombus area? Rhombus area is here. That is rhombus template. So we say this area by diagonals, area by, yeah, it's geometry, area by diagonals, and this 28.87, that is 485, L485, so it's L485, and we'll say that here it is L485, we got this. That's an important point here, we have understand. This we will take here and deduct off from this. So up and down triangle, we have this area minus 6, now this is very small, it's left now. So what's the total area of both apex up and apex down triangles? That's what's important. Sum of L 475 here minus this, minus plus this. And this plus this is this one. So area rhombus diagonal, we say rhombus diagonals to be calculated here. WOH is called cos 60. In that triangle, in that triangle we can say this rhombus we can use for calculation purpose. We have H, and that's the diagonals we can calculate. As we did before, it's not a big deal. So rhombus diagonal, this is down cos 60, and then we can select 60. So we got this diagonal H1, both diagonals. One is H and one is H1. I say here, this is I say here, this is H1. This is H, I say, and this is H1 this way. Both diagonals are there. The vertical is here, H, and this H1 here. So we can say that H and H1 we got both according to our trigonometry. So one is 5 vertical and this is 2.89 horizontal in that rhombus at apex. So after that, rhombus sides is a 5h square plus 0.5h square on the root, and rhombus area we have this. So we move forward now. Rhombus is there. We go on to see perimeter. We have covered area. Perimeter is also very important because it's a very complicated figure for purpose of computation of area and volume. But it's interesting, It's really interesting. It's already 5 o'clock. I can move further and more. Let me finish this. Now, and we'll see after that move forward or no. Sorry. I think other one I'll do later on because it's interesting as well, but we cannot. I don't have time today, so we'll just go there and see where I was. I think somewhere here. I think so, right? Yes, I am here. I was here. So what we did? Yeah, it's there. It was here. It is here, I think, is it? Yes, it's there. So okay. So we see now parameter. Parameter. Now diagram apex up we have, and diagram apex down we have. Both we have. Diagram apex up. I says diagram apex up. Arm, we have numbers three arms we have, right? Which three arms? Again I tell you, I'm talking of these three arms. These three arms, these three arms or these three arms. So we have these three arms, and then we say what we do with that. Parameter arm 3, length external 30, right? We are taking 10, so it is 30. Total total meter 3 external. So there are three arms. So one is 30, other is 90. And length internal, that's the point here. Length internal J475. That's the internal length is this one. We worked out there. This internal length. Total length is 3 into internal. So 3 into internal equal to, this is internal is 21, so 3 is this one, and total is, you can say, these three numbers and these three numbers. We got this parameter we got, right? Because we already worked out that parameter we got now. Now apex down, we are talking, this is about in. It's about in, because here if you see parameter here, you'll find here this full parameter, we have to deduct something out of this. We got crossing here, right? So this we have to take out from this, because it cannot be considered parameter, these humbuses, and we have to take out internal one, this only, and we got total external and internal lengths. Now go to apex down. There are three arms, right? Then length external is 30 and length internal is this. For 3, length external is, length internal is now 3a minus 2b. Solve to this. 3a minus 2 is equal to this, which is same as this one. And total is 3 is this one. So what is it? Deduct rhombuses. Rhombus we have to deduct. It is 6 into 0482. 0482 and the 6 numbers. So 6 numbers are these. That is 60482. This is 0482 and this is here 4a. So we can say 6 into 0482. So we got this, right? Because we have template of rhombus here. Template of rhombus. We got parameter from here, and we deducted that parameter because we put same value here in this rhombus. We put same dimension as it was here. That is, rhombus. We got this value of A of this from the calculations, and we use that one, rhombus calculations, and we got this this here parameter. We all these angles we have worked out already there. Rhombus hypotenuse we got here, which is 10 in this case because that is this one here, formula wise, and we got these deductions here. So it is deduct rhombuses, and total external internal is this one. This is 4. So we got this. So total area and perimeter we have. So 3D volume, cubic meter is apex up and down, net area into depth. This is that area, and 475 is net area. This is net area into this is depth. Depth is 6 into 0482, and that's this one. We got this is 3D volume, so apex up and down net area into depth, and 475 4 R478. That's here R. Extrude volume 3D is this 10 meters, and 475. This is total meters. So we have volume, extrude volume, up to the vertical 3D is this. So we have 3D surface area, and that is here. So we got both informations. It's really very you can say, complicated, not so easy. Unfortunately, I can't show you my AutoCAD because in this document share AutoCAD cannot be shown, but I have for you another one, that is, this is here combination of swastik and I'm sorry, this is there. Then I have to say, I have to here another app, that is swastik one number inside and six number outside. Shakti is that is combination here. This is the yes. Is that yeah? It's this one. This will discuss this how to do this. Next one. I'm not going very fast on this because it's complicated and we'll be sure about this. We have another one, and that's star here, we have other one here, and then we have here after that, after that you can say this is also I still not finished. I'm working on this, so I'll take another time with you. So what we did today, let us see in our nutshell what we did today. Something, we started with swastik. We started with this swastik, this swastik. We started with this, and before that we did this one swastik, and we did cruciform, and then we did swastik, Shakti and David. Then we did combinations of swastik and cruciform, and of course we have gone through this. Just now it's talking of, and we'll see how to manage this more and more. And for information, I'm trying to say that I'm also trying to push some lettership like A to Z in this, which is also very, very interesting one. And we'll do that one. This lights problem now. Lights not full, so I cannot say that I can do everything. Already 1.5 hours is gone. I want it for 2 hours, but no problem. I'd like to take next time. I understand that I'm just trying to give you my understanding, my intellectualism and experience, how to use spreadsheet best way how to use this, so that you can professionalize your computation skills. You can use your own method, no problem, as far as cells are linked correctly, and you can define them to yourself and to whom you submit or to whom you give service. Means you have to keep in mind that it should be done professionally, and every information should be taken up. That's minimum requirement in this. So with this, I talk to you next time, maybe tomorrow or some other time when I get 2 or 3 cases more, and then we'll take up total roundup what we've done so far. It takes actually, when I work on this on myself, when it was easy templates there was no problem, but now templates are getting complicated because I have to use 2 or 3 templates for every case and to link them and to understand them, and maybe there you find some error as well, so you can correct that one. This doesn't matter because sometimes there can be oversight on cell references because it happens. So I would say that we should not mind that, but we should be very careful about this. Therefore, I can say that I will take your permission now to leave, because this is not very fast. This takes time, lot of time. Sometimes it takes many hours of one case, and when I say 4 or 5 cases I give you, it means work of many days, because it's not the fastest thing. You have to change many things many times. So my dear friends, I'll take your leave now with thinking that You may try to do yourself if you wish. It's up to you if you